Today let's see how this ground slash can be done in Unreal. I have previously created this effect for Unity and it turned out really cool. And now I have decided to show you how you can do it in Unreal Engine 5. It's full of tricks, from Niagara to blueprints, from material editor to mesh creation. You are going to learn a lot. So let's jump right into this. Oh, and I made this entire project along with many others available on my Patreon page, links below. So let's begin by creating a new Niagara system, an empty one. Rename it to NES_ground slash and double click to open it up. Once inside, with right click, we can add an empty emitter, which is gonna be for the slash mesh, which essentially means down here in the render, we can remove the sprite render and replace it with the mesh renderer. And let's add a spawn burst instantaneous in the emitter update so we can see something. Here we go. And now for the mesh, we are going to use this one right here, which I'm going to show you how to create in Blender. So let's start by selecting everything with A and pressing delete so we have a clean scene. We want to press Shift A to add a Bezier curve. I'm going to press 7 in the numpad so we go to the top view and I'm going to rotate it -90 degrees in the Z axis, and then we can press tab to enter in edit mode. And I'm gonna select this handle right here, and all we gotta do is push it more or less around here. As you can see, we have kind of a slash shape. If you go right here to the Bezier tab, in the geometry drop down menu, we can extrude an amount of 0.3 more or less. That's enough. And that's when we start seeing something. Let's go to object mode, and from here we can convert this to a mesh with Alt-C. And by pressing tab we can go to edit mode, and with Ctrl R we can add an edge loop right in the middle. Press escape so it stays in place. While holding Shift and Alt, I'm going to select this vertex and I'm gonna go again to the top view with 7 in the numpad and push it with G locked in the X axis. More or less this amount. As you can see, we have some thickness right now. I'm gonna scale this down with S and lock it in the Z. We don't need this to be so thick. And then we can take care of the UVs by creating a new window, drag this corner down here on the left, and on the top left corner we can go ahead and select UV editor. And if we press on this little icon with 2 arrows, we can now select this vertex up here with B, and in the right window we can see which vertex we have selected. And in this case it means we need to rotate this. Select everything in the UV editor and rotate it -90 degrees. So basically these vertices are on the left. And if we select this vertex on the right, as you can see, we have the bottom edge loop, and we want to go ahead and in the UV drop down menu turn on constraint to image bounds. This will allow us to push all of these vertices with G, lock it in the X, push it all the way to the left until it overlaps with the other vertices. And since these vertices on the mid represent the front of our slash, we can push this all the way to the right, just like this. This way we can create a gradient texture and the front of the slash will be brighter. UVs are extremely important to map a texture properly. Now if you want, you can go ahead and shape a little bit this until it looks a little bit better. In my case I'm gonna push this vertex to the left so it becomes thinner at the top and a little bit thicker towards the bottom. Oh, and by the way, these 2 vertices right here, you can scale them down in the Z axis. You can press 0 and then enter until they are overlapped. I think it will look a little bit nicer. Okay, so once you have a shape that you like and that you are pleased with, we can go ahead and let me just get out of see-through mode by pressing Z, and with spacebar I'm gonna go ahead and search for shade smooth. You can find it up here as well in the object drop down menu, and this will make it look a little bit nicer. From here we can export this in the file drop down menu as an FBX. Make sure you rename it, and up here you turn on selected objects so you export only the slash. And once you have the mesh, don't forget to assign it to the mesh renderer, because now we are going to need a new material. So with right click, let's go ahead and create a new material. I'm going to simply rename it to m_material01. The first thing we can do is to make sure this works with whatever color we choose in Niagara. And for that, we can search for particle color. Another very useful thing is a texture sample parameter 2D, which is going to represent our main texture. From there, we can create two multiply nodes by holding M and clicking with the left mouse button, where we are going to multiply the RGB from particle color with the RGB from the texture, and connect this to the emissive color. Then we can multiply the two alphas and connect them to the opacity. Even though it's gray, we can now go to the details of this material and in blend mode say it's additive. And for the main texture, we can assign this texture right here, gradient horizontal, which is available for free on the link below. It essentially goes from transparent to fully white, and well, that's it. We can save our shader, our material, and go ahead and create an instance out of it. I prefer to use the instance than the original material. Now let's go back to our Niagara system, and in the mesh renderer, let's turn on enable material override, and in here we can add a new array element for the material we just created. And here we go, it's beginning to look like something. Now let's control how much time this leaves. On the initialized particle, we can say the lifetime is 1.8, and let's say the color mode is direct set, so we can use a very bright color like 80, 22 and 6.6, which will look something like this. And from there, if you want to adjust the scale, you can do it down here in the mesh scale mode, by the way, uniform or non-uniform. Now let's make sure this grows a little bit in the beginning by adding on the particle update a scale mesh size, and on this arrow let's convert this vector to a float, which will be very useful to control the size of this with a curve. We can click on this template, the first one, add a key more or less in the middle, say it's at 0.3 down here with a value of 0.9, so it grows fast in the beginning and then it stays pretty much the same size. I'm going to select all of these keys and turn on auto, so we can get these nice curves and fix the first handle to something like this. And at this point, this is what we got. It disappears out of nowhere, so what we can do is, with a scale color on the particle update, disable scale RGB, but say the scale alpha is a curve. And from there we can say that the first key goes to around 0.4, which means it's still visible around half of its lifetime. And then we can select this and select auto mode so we can have these handles to create this curve. As you can see, it fades out towards the end. Great. Now let's turn on local space so this follows its parent object and we can shoot this basically with blueprints. And while we are here, let's add another emitter, an empty one, for a light. Down here we can remove the sprite render and replace it with a light renderer. And then add a spawn burst instantaneous on the emitter update, and this will essentially emit one light. In initialized particle we can say it leaves exactly the same as the slash 1.8, and for the color we can copy the color from the slash. Copy and paste exactly, but in the value increase it to 8000 so we can see something. And all we gotta do now is in the position offset push this a little bit up, otherwise it will intersect the ground. A value of 50 will do fine. From there we can hold Alt on the scale color of the slash and drag and drop it to the particle update. It will create a duplicate. One last thing we can do on the light renderer is turn on alpha scales brightness, which means the scale color will influence the brightness of the light. Increase the radius to 100. Oh, and let's make sure this is also in local space. And just out of curiosity, if I drag this to the scene, this is how it looks. We have the light and the mesh itself. Great. Let's add another emitter, this time for the decal, bright. It's a text that is going to adapt to the ground below and it's going to be bright. Which means down here in the render we can remove the sprite render and replace it with the decal render. And on the emitter state, let's set it to self instead of being equal to the system, because we want to make sure that the loop behavior, it's only going to play once with a loop duration of 1.8, which is the same amount of the slash itself, the mesh. From there, we want to use a spawn rate or a spawn per unit But on the spawn rate we can say it's a curve, and it's going to keep on emitting until more or less half of the loop duration. From there it's going to go to 0, it's going to stop emitting. I'm going to select all of these and say it's auto. And then on the scale curve, we can control the spawn rate and say it's 20. Now let's duplicate this original material. We need to modify this material so it works with decals. And on the material domain, we can say it's the fair decal. And the blend mode is translucent. And for this to work as a decal, we need to replace this particle color with a decal color. Replace the connections and that's it. We can actually already replace this text down here and use one that comes with Unreal, for example the light beam fall off 02. If you turn on show engine contents, this will show up, by the way. There we go. Now let's save this and create a material instance out of this so we can use it in our decal bright down here on the decal renderer. Search for the material we just created, assign it here, and then let's adjust the lifetime. We don't want that much, something like 1.6 for example. We'll leave a nice trail behind. And yeah, we can copy the color from the slash mesh and paste it right here. Let's just say it's direct set, but decrease the value to around 40. And if we test it again in our scene, this is how it looks. I will show you in a moment the blueprints that I have. For now we can move it back and forward. Now let's go back to Niagara. And on the particle update, let's make sure that this shrinks over time. We are going to use set parameters, and then up here on this plus sign we can search for decal size. There's very specific variables only for decals. Decal size will do just fine, but we want to break this vector. You can search for make vector and it will separate each axis, and then we want to say 50 for the x and 150 for the y, but the z is going to be a curve. The first key is going to be 0, but then we can add another key more or less at around 0.2 and say the value is 1, and then select all of these and say it's in auto mode. So we can control these handles and create this curve, and then we can scale this to around 35. And as you can see, they will shrink, they will become thinner and thinner. It will create a very interesting effect once this is moving. Let's also make sure this fades out with a scale color. This time let's turn off scale alpha and scale the RGB, but we can convert it to a float and then convert it to a curve. And let's just select the handles and say it's in auto mode. Here we go. And then it fades out. And as you can see, it looks much more interesting once we have the blueprints working to add motion to the ground slash. So how does these blueprints work, you may ask? Well, I'm gonna give you an overview in case you are interested. Basically on my scene I have a spawn blueprint that essentially once the game is running, it checks if we press spacebar with this input system, and once we press spacebar it will spawn the ground slash blueprint. This blueprint right here is where most of the magic happens. In here we have the Niagara with the ground slash, and attached to it we have the follow ground component. Basically once the game is running, we use this line trace function that it starts on the target itself, which is the ground slash, and it will shoot a vertical line only on the z-axis. We can control the distance of that vertical line, and we check if it has collided. If it has collided, we move the owner of this component to that position. This way it will follow the ground essentially. Then on the ground slash blueprint we have this reduce speed or decrease speed, which will basically pick up the projectile movement component, which is also attached right here, which is already available in Unreal. And the component to decrease the speed will check if we have it, and then after a certain delay the boolean to reduce speed will become true, and we keep on checking that, and if it has become true then we do an interpolation of the current speed, the velocity, until it becomes 0 essentially. And that's how this works. We make sure the ground slash follows the ground, and then we decrease its speed, creating this very interesting effect. Feel free to try to replicate it, or you can get access to this project on my patrons page, links below. Another thing we can show you is how to add debris to this. I'm gonna use this 3D model right here. If you have Blender, let's see how we can add some debris to this. So if you go back to your Blender file You can go to edit and in preference, in add-ons, you can search for cell fracture, turn it on. And then we need to add the cube with Shift A, and with spacebar I'm gonna go with cell fracture, which you can find in objects, quick effects. This panel shows up and we can increase the source limit above 10. Recursive, we can set it to 1, and it's important that we set the noise to 1, and then we can press OK. And we get a fractured cube, which means now you can select 1 or 2 debris from here and delete everything else. Once you have these 2 debris, what's important is that you select them and you press Ctrl A to apply the rotation and scale. From here now you can select both of these debris, go to File and in the Export select FBX, turn on selected objects, don't forget about it, or otherwise you will export the slash as well. Once you have the debris, you can assign a basic shape material, which comes with Unreal if you turn on Show Engine Content, for example. And from there we want to set the emitter state to self, loop behavior to once, and the loop duration to 1.1, for example. Let's make sure this emits something with the spawn rate in the emitter update. We can use the same technique, a curve. Let's say it's in auto mode. And let's scale this to spawn 30 for the rate, for example. And lifetime of around 1.5 seconds should do just fine. And let's add some randomness to the mesh scale, between 1 and 2. From there we want to add the sensation that they are moving and being expelled from the ground, right? So let's add a velocity on the particle spawn. Yeah, we get a few warnings, but if you click Fix Issue, it will add the solve forces and velocity automatically. And from there we can say the velocity speed is random, between 250 and 450, that's the values we think look great. Oh, and on the cone axis, it's not on the X but on the Z. And then we can decrease that cone to around 20. We will see how it's looking in a moment. For now, let's add randomness to the rotation with initial mesh orientation. Make sure it's random up there, and that's it. Here we go. For now, let's make sure they shrink towards the end of their lifetime with the scale mesh size in the particle update, where the first key is around 0.7. And then add another key, push it a little bit forward with a value of 1, and then another key closer to 0.5 with a value of 1, and say this is all in auto mode, so we can have these Bezier curves and control them to create something like this. We get a bunch of debris going up and never coming down, but that's an easy fix. If we use gravity, we can leave it as it is and then add collision, so it collides with, well, everything. But we need to decrease the bounce to around 0.1 and the friction bump it up to around 20. And this is what we get. As you can see, it looks like it's piercing the ground and there's debris all over the place. Now it would look even much better if we had debris closer to the ground, static to the ground, right? So let's duplicate this debris air and call it debris ground. I'm just going to switch the mesh, but you can use the same. And the loop duration will be longer, like 1.5. And then for the spawn rate, we can use this template and say the handles are in auto mode, and then we can say the scale curve is 80. These ones will live longer, like 3, and we need to offset them in the Y and on the Z around -20, -30. They can be smaller in terms of size, at least because I've changed the mesh. We don't need the add velocity, let's remove it. And for the scale mesh size, I'm just gonna make small adjustments like this. And finally, we can remove the gravity and the collision and solve forces and velocity. Let's copy and paste this because the debris is ground 0.1, where for the left side, now for the right side, all we gotta do is adjust the position offset, make this positive on the Y. And this is the end result. I really think this is a great exercise. We have seen a little bit of everything and it gives you an idea of what you can do. I then obviously added a few more things like some ribbons, like some particles and whatnot, but the core of the effect is essentially that. I made all of this available on my Patreon's page in case you want to get your hands on this project, along with many other projects and assets for your games or to study up close for Unreal and for Unity and Godot. It's all in the link below. Want to say thank you to each patron that supported me last month, and a quick shout out to the top tier patrons as usual, which are Alberto Sageras, Alan Alston, Andre Ripa, David Molina, Diego Marques, Lua Ama, Eric, Phoenix, Frosty40, Grub Lab, Ivan Jacobi, Casey Miller, Leandro de Ricio, Leon Holt, Matt Moran, Matthew Parker, Mihaita Nastase, Mike Bell, Oitsk, Owen, Awesome Safuele, Pay Easy, Pierre Mario Roux, Pradip Sen, Radioactive Bullfrog, Revenant Games, RVR, Shan Aguilar, Barry Suta, Whatever Marta, Will Polian, Vlad, Minja Kim, and Sang Yango. So thank you all for watching, I hope you have enjoyed, and I hope to see you in the next one. Thank you, bye.